All right, Chem 1 students. Today I'm going to be doing problem 1215 from the book. Sorry, 1216. And this is a heat of vaporization problem. It asks, from the data below, calculate the total heat needed to convert 0.333 moles of gaseous ethanol at 300 degrees Celsius and 1 atmosphere to liquid ethanol at 25 degrees Celsius and 1 atmosphere. So to get an idea of what's happening here, let's draw a diagram. This is in your book, and it'll help you understand what's going on. So we start off at a gas up here at 300 degrees Celsius. And we're cooling this down to 78.5 degrees Celsius, which is the boiling point. So we can call this stage 1. And during stage 2, what's happening is that all this gas is being turned into a liquid. So during this time, no heat is gained or lost. So because all the heat is put into converting all this gas in a liquid. So during this stage, there's no temperature change. No temp change. And so now we're still at 78.5 degrees Celsius. And then now we further cool this down to 25 degrees Celsius. So now for each of these 3 stages, we'll assign a Q value. So Q is heat. So Q1, Q2, and Q3. And what we use for each of these stages, you guys should probably know this. We use 2 equations. Q equals mc delta T, which kind of looks like MCAT, and Q equals mL. So the first equation is used when there is no phase change occurring. So there is a change in temperature, as you can see here. The second equation is when you use this equation when there's a phase change occurring. So you got a gas here, but you got a liquid here. And you have liquid plus gas in this stage. And so now let's start actually solving this problem. So you're given a couple of values. You're given the heat capacity of the gas, C, which is 1.43 joules per gram Celsius. You're given the C of the liquid, which is 2.45 joules per gram Celsius. And you're given the heat of vaporization, delta H vap, which is 40.5 kilojoules per mole. So since you want this answer in moles, it's crucial that you convert kilojoules to joules by just multiplying by 10 to the third joules per mole. Okay, so now that we have all the values given, now we have to find some stuff. So for this equation, we need mass. So we're given moles of ethanol, so you know how to convert moles to grams, so we use the molar mass. So you have 0.333 moles ethanol times the molar mass you guys can find out is 46.07 grams per mole. So when you multiply all this out, you have approximately 15.34 grams. So now you're ready to solve your equations. So Q1 is equal to m, your mass, 15.34 grams, times your heat capacity for gas, which is 1.43 joules per gram Celsius, times the change in temperature. So change in temperature is always final minus initial. So you end at 78.5 degrees Celsius and start at 300 degrees Celsius. And all the units should cancel out. So grams cancels out, and then this value, the temperature should cancel out. So you know you have the right answer because your answer is in joules. And Q1 in this case is approximately negative 4,859.28 joules. It's negative because we're cooling things, and so heat is being given off. So now we're in the second stage, Q2. So now, since our L is the heat of vaporization, which is given in joules per mole, we can actually change this equation into NL. So N is just moles. So Q is equal to the number of moles we have, 0.333 moles, times our heat of vaporization, times 10 to the third joules per mole. So moles cancels out, your answer's in joules, and that's approximately negative 13,486.5. Also, I forgot to add a negative sign here. Because you're going from a gas to a liquid, vaporization, the heat of vaporization is actually negative. So if you're going from a liquid to a gas, it would be positive. So it's the first case, gas to liquid, so this is negative, and that's why your answer is negative. So now that we're at the start of stage 3, we can use this equation again. We still have the same amount of ethanol, 15.34 grams, but now, this time, since we're in a liquid phase, we use the heat capacity for the liquid, which is 2.45 joules per gram Celsius. And now the change in temperature is 25 degrees Celsius minus 78.5 degrees Celsius. And so now this should give you about negative 2,010.86 joules. All right, so now we're ready to solve the entire heat change, so Q total. So Q total is just all the Q values added up, Q1 plus Q2 plus Q3, and that should give you a value of about negative 20,356.64 joules. And that's how you solve a heat equation, or heat problem. All right. We're good.